Hello guys, let's talk about the differentiation in integration. Okay, what is the reason that the formula is like this? Okay, y is equal to xn, and integration formula is this, and differentiation formula is this. Okay, let's move on to the board. See, but this is differentiation. Okay, this is differentiation. Okay, and this is integration. So we have to derive the what formula, So why this formula? Proof of the formula, okay. So that y is x to the power n, okay. The function is this, okay. Y is equal to f of x, right? So we know that y is equal to f of x, right? So put here a little some change in y, okay. In the same way, the x will be also changed, right? F of x plus del x, okay. So if I take this y this side, this will become what? Del y is equal to f of x plus del x minus y. Y we have know that y is equal to f of x, right? So I put here direct f of x, okay. So now divide both sides by del x. So we get what? Something like this. This is called the first derivative or the differentiation, okay. So del y by del x is dy by dx, which means first derivative, right? So now put the value. Function is what? Y is equal to f of x is equal to x to the power n, okay. So if I put a function, instead of function we put a x plus del x instead of x, okay. So if I put a x plus del x instead of x, this will be, function will be look like this, right? Of course, because instead of x I have to put what? X plus del x, right? So I put here, got it? Minus f of x is what? X to the power n. So I put here x to the power n divided by, got it? So this is what we call the derivative. So we have to find the first derivative, which is what? Del y by del x, right? So yeah, now if I make a limit, okay, del x tends to 0. So what happens is, if I solve this using a binomial expansion, this can be written as NC of 0, right? X to the power what? X to the power n minus 0, which is n, and the second term is del x. So this will have a power 0, right? So n raised to power 0 is what? So n raised to power 0 is 1, right? So let's don't write whatever it is. So plus okay, x to the power n del x 0, okay. So n factorial, yeah, got it. So this is what something like del x, and this will be, second term will be NC of 1, right? So this is binomial expression. So I have to put the n minus 1, this is n minus 1, and del x power of this base 1, what is 1, right? So on, NC of 2, x to the power n minus 2, and this will be del x square, right? So on, right? Got it? So we will get later minus xn, right? So this is NC of 0 is 1, right? So x and xn cancel, right? So del x will be also cancelled. Right? Now what left will be, so limit del x tends to 0, right? So if I put here del x 0, so what I left will be, see, NC of 1 x n minus 1, right? So del x, this del x will get cancelled, right? So I left this only, okay. Plus there will be left in x n minus 2, but del x cancel, but there's a del x will be left, right? So again there will be, so this is NC of 2, NC of 3, x to the power n minus 3, del x cubed, right? So this is del x squared, so on, right? So there will be a del x, which means if I put a limit, del x tends to 0, so 0 multiplied by any number is 0, right? So this becomes 0, this becomes 0, this becomes 0. Only left is this one, so this NC of 1. So and we know that NC of 1 is what? NC of 1 is equal to n, right? N factorial upon what? N minus 1 factorial, right? So this will be n minus 1 factorial, and might be cancelled, right? So we get what? N. So n, this is n, x to the power n minus 1. So when del x tends to 0, what we get is dy by dx is equal to n x to the power n minus 1, right? So when limit del x tends to 0, so and the del x will be tends to 0, which means the differential is very small, right? So we have to change del y by del x into dy by dx, okay? But now we get what we have proved, right? Dy by dx is equal to nx to the power n minus 1, okay? Now talking about the integration, y is equal to x to the power n, and integration of x to the power n is x to the power n plus 1 divided by n plus 1, right? So we have to prove this, okay? How can we prove is y is what x to the power n, right? So we can use this as a d by dx x to the power n, okay? No. So from this, first we have to take this, okay? Dy by dx is equal to nx to the power n minus 1, right? So integrating both sides, okay? I had to integrate both sides, okay? So when we integrate both sides, so putting y is equal to x to the power n here, so this is become n is constant, so I take outside, so this become like this, okay? D by dx and integration is opposite, right? So they will what? Cancel each other, okay? Got it? What will they will cancel each other, okay? So this will be cancelled here. So now we get what? X to the power n is equal to n integral of x to the power n minus 1, right? Put n is equal to n plus 1. Substitute, okay? So instead of where there is an n, you put n plus 1. So this will become what? X instead of n plus 1. Instead of n plus 1. Instead of n plus 1, if I put here instead of n plus 1, this will become like this, okay? So what we left will be, if I take this side, this become what? X to the power n plus 1. Sorry. X to the power n plus 1 divided by n plus 1, right? Which is equal to 1 cancel, this become integration of x to the power n. So if I take this right hand side to left hand side, this becomes integration of x to the power n, or we can put here dx is equal to what? X to the power n plus 1 divided by n plus 1. Let's see. Got it? So this is the what we are finding, okay? So using the differentiation, we can find the integration, right? I hope you understand. That's all. Thank you.